Word. So on this packet, we're just going to finish up everything that we haven't done, and then we'll be finished, and I won't start anything else. You need to make sure that you have the calculator inactive part done before you come in on Monday. Does that make sense? Is everybody good? All right. So a couple of these are just writing things down. A couple of them on the calculator, a couple of them are on Desmos. So that's why you need everything. And like I said, once we're finished, we're finished. So it should be a fairly short Zoom. But then, like I said, go ahead and do your calculator inactive part, and it's only 15 questions, and you should be able to do it fairly quickly. Okay. So it says every 10 years, so that's the first thing you need to know. Every 10 years, the census counts how many people are living in every town in the United States. The 2010 census showed that 1,000 people were living in Appleville and 4,000 were living in Bridgetown. So I'm just going to put an A and a B. And in 2010, 1,000 were living in Appleville and 4,000 were living in Bridgetown. The population of Appleville is predicted to double every 10 years, and then Bridgetown increases by 1,000 every 10 years. So if Appleville doubles every 10 years, so that would be 2020, what does double mean? If they're at 1,000, what will double be? 2,000. Okay. Bridgetown, it says increases by 1,000. So if they're at 4,000 and they increase by 1,000, what will they be at? 5,000. It wants to know what's the first census year that will show Appleville larger, 2,000, 5,000. Appleville is not larger yet. Okay, so we got to go another 10 years. So we're doing 2030. Double Appleville. So Appleville will be what? 4,000. Add 1,000. So Bridgetown will be at 6,000. Appleville is still not large. So let's try again. We're going to go to 2040. Double Appleville. Add 1,000 to Bridgetown. Appleville is finally bigger, right? So what year is that? What year was it? That's it. That's all you guys got to do. Right, so in the next one, it says 2 stores have movies to rent. The first store charges a $12.50 per month membership fee. Now this per month is what's going to throw you off. So mark this per month out. The membership fee is what you pay in general, okay? So you pay to be part of the club. Plus $150 per movie rented. The second store has no membership fee but charges $350 per movie. So this one is $12.50 plus $150 per movie. We've been writing equations since the very beginning of the year, so you should know how to write that equation. So how do I write the second store? Charges $350 per movie. Anybody? Do they have the $12.50? Nope. So just what? Just the 350X, right? Yeah, you were right. Just take off the membership fee. All right, so it says, what is the minimum number of movies a person would need to rent a month for the first store to be a better deal? First store to be a better deal. So here's how you figure that out. You want the first store, this one, to be bigger than that one. It does not matter. Anytime you see this, you're going to set them equal, okay? So that's when you know they're the same, and then you're going to go one above that, okay? So we're going to set them equal, and we're going to let Desmos do the work. All right, so I'm going to go on my Desmos calculator. You could solve this by hand, and that would be fine. It's up to you. But I just like showing you on Desmos more and more. Internet's been kind of slow today here, so just FYI. We have $12.50 plus 150x. Let's see. I'm gonna go ahead and put equal, y equals. And then the second one, y equals 350x. Minimize this, get it out of the way so we can see. We're gonna find out where they cross. You guys see where they cross? Where is it that they cross? What's it say? Can y'all read that? You can't read it. What's it look like? You're fine. 6.25, so 6 point something, regardless, it's 6 something, right? Is everybody good with that? All right, so can I rent 6.25 movies? What's the next amount of movies I can rent? 7 is what you're looking for, okay? So even though, I'm gonna switch it back so you guys can see it. We got that x equals 6.25. We're gonna go up to 7 because we can't rent 6.25 movies. Okay, let me show you this. You can solve this equation. You guys don't really like decimals, so that's why I didn't solve it for you. If we're solving for x, we have to get them on the same side, so we're going to subtract 150. We get 1250 equals $2x. You can just put 2x. Divide by 2, and you get $6.25. So you can do it by hand. You guys know how to do it by hand. But a lot of you guys just need a calculator just to hold your hand. And then we got to go one above to make sure that we rent it. Okay. Any questions on number 5? All right. We did number 6. I think we got to number 9. We did number 7. We did number 8. We're at number 9. All right. So anytime we see a table, what do we do? Put it in calculator. Put it in stat. So I told you we're going to use Desmos a little bit. We're going to use our calculator a little bit. We're going to use everything. So we're going to go to stat and edit. And I already have these values in because I did it this morning. I'll give you a minute to put them in. And I'm going to read it while you guys are doing that. So this is the scores of 7, or the number of hours 7 students studied for a math test and the grade of the math test. It says, how does Amanda's test score compare to the score predicted using the linear best fit line? So we're going to predict using the best fit model for 3.5. So what you're doing in your calculator, when you do that stat calc linear regression, is you're finding that best fit line. What's crappy about this one is that it's decimals, okay? Still not bad because you can use your calculator. So here's what you do. I'm going to write these decimals down. 5.187x plus 76518. And I just do 3 decimals so that I can get it as accurate as possible without having to worry about rounding, okay? That way I know I'm not going to screw it up. It wants to know 3.5 hours. That means we want to plug it in right there, okay? We want to plug in right there. So in my calculator, 5.187, I'm going to plug in 3.50 plus 76.518. And I get 94.67. All right, is everybody okay with where I got that from? All right, we're going to go back up. We're only looking at Amanda right here. She got a 93. So did she score about 5 points lower or higher, or about 2 points lower or higher if she got a 94 from a 93? About 2 points. So we're going to mark these out. We know this is not right. And did Amanda get 2 points lower or 2 points higher than the 94? Lower. That's how you do. That's it, y'all. Just make sure you read the question really good. We didn't do number 10. All right, so they talked about the correlation coefficient. That is R in your calculator. So it said R equaled 0.85. And if you guys can remember what R means, we want R equals 1 so that we will have a perfect line. So it'll be perfect. So anything really close to 1 is good, which means it's strong. And that's probably anything 0.6 or higher. 0.6 is kind of iffy. Think about your grades. If you got an 85 on a test, is that a good thing or a bad thing? It's pretty good, right? 85 is pretty good on a test or on a final exam. 85 is really good, right? All right, so which can be concluded based on the correlation coefficient of the data. There is a strong relationship or a weak relationship. We'll start with the beginning. Is it strong or is it weak? 85. Is that a strong grade or a weak grade? It's strong, so we can mark out C and D, and then we'll figure out the other two. All right. Then, if it's positive, remember it's increasing. If it's negative, it's decreasing. So it's kind of like the slope. If it's a positive correlation, that means it's going up. If it's negative, it's going down. So look at this first one. It's a positive 0.85 right here. There's a strong relationship showing the number of days increases, the height of the plant increases. There's a strong relationship showing as the number of days increases, the height of the plant decreases. So which one is this one? If it's positive, what does it do? Increases. So is it increases or decreases? Increase. That's all you do, guys. That's it. All right, we have 2 more and we'll be done. 2 more. Going to number 12. We did number 11. Number 12 is Desmos, and this one will take just a few minutes on Desmos, okay? Number 12 is Desmos. The vertices of a rectangle are located at 1, 2, 5, 0, 2, -6, and -2, -4. What is the area of a rectangle? How do we find the area of a rectangle? Length times width, length times height. I don't care how you say it. You know what it is. Length times width is what I say. So remember, we need the 2 sides, right? All right, so this is what's really cool about Desmos. I'm going to put these coordinates in. I'll show you how to do it. We're going to have parenthesis, 1, 2, close your parenthesis, comma. Open your parenthesis, just like you see it on that paper, 5, 0, close your parenthesis, comma, 2, -6. I would suggest that you make sure that you're trying to put this in, comma, -2, comma, -4. I'm gonna hit the home button since I went everywhere on this screen so that I can see. All right, I need a length and a width, okay? Doesn't matter which side you choose. I'm gonna choose this top, so these 2 points, If you guys touch these 2 points, it'll tell you what it is. So this first one that I'm touching right now is 1, 2. And this one is 5, 0. Okay. How do I know how far away that is? Because this is a diagonal and I can't tell. Desmos does it for you. Let me show you how it does it. You ready? You might want to write this down. You type in the word distance. You have to know how to spell it. Type in the word distance. You put in a parenthesis. You type in another one so you can put the coordinate. That coordinate was 1, 2. And our other coordinate was 5, 0. You guys see that? 4.47. One, 2, 5, 0, 2, -6, -2, -4. Everybody good? All right, so I'm going to put that on my paper, 4.472. And again, I go 3 decimal places. That's just me. All right, so then I want to try one of the links, and I can use the 1, 2, that's fine, and drop over here to this one, -2, 4. I'm real lazy. I can copy and paste this. You guys know how to copy and paste? And I want to do -2, -4 instead. And it tells me it's 6.708. $4.472 times, you guys know how to do times, Shift X, or you can go down to your functions down here and do times 6.708. And what do we get? 29.999, which rounds to 30. Perfect. So we go back to our paper. Why are you being weird? We got 29.99, which rounds to 30. Very good. So remember that distance, they'll ask you a lot, probably a couple distance questions, and then you put in your coordinates. And then you don't have to worry about actually doing the work, okay? Remember to do distance by hand, you do Pythagorean theorem. So if we get it on, let's do this. What do we have? 1, 2, and 5, 0. 1, 2, and 5, 0. We would do Pythagorean theorem. Remember, rise over run, 2 squared plus 4 squared equals c squared. So I did teach you how to do that. And then you would figure out what c is, and that would give you that decimal right there that you had already. Okay, so you do know how to do it by hand, which when we do the calculator inactive on Monday and Tuesday, if we have any of those, that's what I'll be showing you. All right. Otherwise, if you have Desmos, use it. Use Desmos. Try the best you can. All right, then we had number 14. So I'm going to give you some things to go with first to show you. So we have skewed left, skewed right, and symmetric. Guys, remember we worked with box plots? Symmetric means that box is exactly in the middle. So I'm going to show you what these look like instead of making you pick it out. I'm going to show you what they look like. So the bottom one. This bottom set of data, I'm going to show you it. Here's how we do it. Here's how you would figure it out. Okay, I'm gonna put this bottom set of data in. I want you to put it into 15, 25, 35, 45, 55, 65. Delete that out. I'm gonna teach you how to make a box plot on your calculator, okay? If there's anything in y equals, you want to clear that out real fast. Make sure there's no plots on or anything like that because my stats kids use it and everybody else. So make sure nothing's in there. You're going to go to second y equals. So the blue key and y equals. And we're going to hit enter. We're going to turn this plot on. And we're going to go to a box plot. And I like the one with the little dots. Okay, that shows your outliers. Typically in Math 1, you don't deal with any outliers. And I'll write all these steps down in just a minute. And then you zoom 9. Zoom is this key right here. And then hit 9. Zoom 9. See how it's pretty and in the middle? Does everybody see that? All right, so what we did, we put it in L1. We did second y equals. We turned it on. We did a box plot. And then we did zoom 9. So this is another one of those drag and drop. You would drag this set of data up to the symmetric one. You could also graph these on a number line just like you had before. Do your 1 bar stats, plot your min, your max, your Q1, your Q3, and your median. It just takes too long. Your calculator does it so much more quick. All right. So let's check out one that's right skewed. Check out one that's right skewed. So I'm going to go back. I'm going to tell you that this set of data is right skewed. So we're going to edit. The only thing that's different is that the 65 changes to the 115. And we have everything right. We don't have to do anything but hit graph. Check out this box. Which way is the box? You see how it slid to the right? Does everybody see that? So right skewed puts the box on the right. So what do you think the left skew does? Puts the box on the left. And if you look, these values are a lot higher with a little minimum 15. So I'll show you what that one looks like. You don't have to do it. 15, 75, 85, 95, 105, and 115. All right, just kidding. Let me take it off though, just because I put it on the modified. There you go. Ooh, what'd I do? Did I screw it up? It's because I didn't modify it again. Sorry, y'all. There it is. So here's, okay. You guys see, don't ignore this point for a minute. You see how this is slid over? This is why we do this. Notice when I did it the other way, it looked right skewed, right? So this is called an outlier and it shows it as a dot. That's all it is. But the box is what we're looking at and it slid to the left. Okay. Any questions about this? Is everybody okay with this packet? All right. So now, again, what you're gonna do is go do that calculator inactive. So do not use your calculator, do not use Desmos, try the best that you can. I'm not looking really at your grade. I am looking at your grade, but not to give you a grade for it. Does that make sense? Is everybody good? All right, so I'm gonna stop sharing, stop recording.